All right, so intercepts of a rational function are arguably the easiest thing when it comes to rational functions. So again, really quick um, review that we are dealing with a rational function where p and q of x are polynomials with no common factors. I keep emphasizing that because when there are common factors, things change. So other than one, obviously, and then this is our general polynomial. So let's talk about y-intercept. Y-intercept is the easiest of the easy, which is what is true whenever we're looking for a y-intercept for any function is the y-intercept is when x equals 0. So when x equals 0, we can find our y-intercept. So for a regular polynomial, it's always our c value because all the terms leading up to the c value cancel out because you're being multiplied by a variable, which is 0. Now, how many y-intercepts can a function have? A y-intercept can only have one, so it's only one. Why? Because if there isn't only one, it is not otherwise not a function. Okay, so there's only one y-intercept. It's the same rules of any other function that we've done at this point. So you just plug 0 in. For x-intercepts, here's the thing about x-intercepts that changes things up. I don't know why I said it like that. I'm like x-intercepts. X-intercepts, the difference between x-intercepts and y-intercepts is that this is when what equals 0, when y equals 0. So if I have a function like, I'm just going to do y equals a over b. It doesn't really matter. If I have 0 equals a over b, what would have to be 0 in a over b in order for the whole thing to be 0? Well, if b equals 0, it's undefined, right? But if a equals 0, so if it's 0 over anything, b, right? Then I know that the entire thing pretty much cancels out, right? Because 0 over anything except 0, anything not equal to 0, is equal to 0. So that's what makes this easy, is that the y-intercepts, you just have to set the numerator equal to 0. And for this one, we didn't like put what to do, but you just have to plug x equals 0 into the function. So that's it. And then we'll just do some examples. So these, again, are the same examples, but they're already factored. Go back to the first video if you want to go over the actual factoring methods, but they're already factored for us. Now, to find the x-intercepts, I'm going to press enter here. Because I think, personally, to find, the y-intercepts. So let's do y-intercepts in red, and we'll do x-intercepts in green. So to find the y-intercept, I think it's personally easier to do it when you're dealing with the expanded form, not the factored form, because again, when you plug you have to do g of x, right, equals 2 times 0 minus 8, and then so 2 times 0 minus 8 over 0 squared minus 9. These first terms cancel out. And so I get negative 8 over negative 9, which is 8 over 9. So my y-intercept is, therefore, 0, 8/9. And then, so you could do it in factored form, which we're going to do in the next one. But if it's already expanded for you, use that to your advantage, for sure. And then x-intercepts, again, I'm going to set this equal to 0. So therefore, this is my equation. So I have 0 is equal to 2 times x minus 4. And so we know how to take something that's factored and solve. So the 2 is not important when we're solving. So x is equal to positive 4. And so it's basically the roots of the numerator. And so my x-intercept, I only have one. You can have a million, but we only have one for here. It's 4, 0. Let's look at what that looks like on the graph. So here's that function, right? This is our function. Our y-intercept is at 0.8889, which is the y-intercept, and here is my x-intercept, which is at 4, 0. So that proves our point. Let's do another problem. So my y-intercept, I just plug 0 in. So this is going to be a little bit more difficult, but the good thing is that our numerator has that x squared up front, which means that everything is going to cancel out when you plug 0 in. So I'm going to get 0 over something. So my y-intercept is going to be 0, 0. Now, let's say this didn't exist. I would literally just plug in 0, and I'd get 4 times -5 times -10, and then 20 times -6 times 5 times 1. You just multiply the constants together, essentially, and divide. So my y-intercept is 0, 0, and then my x-intercept, so we already know 0, 0 is going to be 1, because 0, 0 is an x and a y-intercept. But I set this equal to 0. I'll put a 0 here, and I solve this equation. So if I set this equal to 0 and I solve, I'm going to get x equals 0 from the x squared, x equals -4, x equals 5, and x equals 10. Now, when we did polynomial functions, we learned about multiplicity and how many roots are at one place. So we know that there's a double root at 0. It does the exact same thing that we've learned, is that when you have an even root, it bounces off versus it goes through. So let's look at what this looks like on the graph. So I have my y-intercept, let's go to y first, is 0, 0. It's also an x-intercept. Then we have our -4, right? -4, we have our 5, and we have our 10. But look what happens at 0. It bounces off. It doesn't go through. So it goes up, hits 0, 0, and comes right back down. And so you would write them as points if it asks you for the actual x-intercepts. Okay, next one, super easy. You would put, I know my y-intercept is going to be, this goes away, and so it's 4 over -20. Remember, keep your signs. So 4 over -20 is going to be -1/5. So it's 0, -1/5. And then for my x-intercepts, I just set my numerator equal to 0. And in factored form, it's easiest. So I get x equals -2 and -1. So my x-intercepts are -2, 0, and -1, 0. Let's look. Here it is. Oh, geez. Oh, that's like a vertex. That's why it's an important point. Okay, so we have -1, 0, -2, 0, and then -1/5 as our y-intercept. And lastly, I just want to emphasize one thing here is that what happens if you have something like this? So for my y-intercept, again, we plug in x equals 0. But what's the problem here? Well, if I plug in x equals 0, I get 0 plus 1. I get t of x equals 0 plus 1 over 0, which is 1 over 0, which is not possible. So but what is x equals 0 in this function? X equals 0 is a vertical asymptote, meaning that when I graph this, I'm going to have something that looks something like whatever, right? Like the reciprocal function. It's getting closer and closer and closer to the y-axis, but it never crosses it, so therefore there is no y-intercept. So the answer is none. There is no y-intercept. There's also possible that there's no x-intercept. That would be if there's no x in the numerator. If it was like 1 over x, like our reciprocal function, there's no x-intercept. Also, let's just do x. My x-intercept is going to be, you just set x plus 1 equal to 0. So x equals -1, right? We set this equal to 0. And so my x-intercept is -1, 0.